We have the following problem. Many banks charge point on mortgage loans. Each point is equivalent of a 1% charge on the amount borrowed, and it is paid before the loan is made as part of closing costs of buying homes. Closing costs include points, title fees, assessor fees, and so on. We have to answer the following subsections. Part A. If 100,000 is borrowed for 25 years, for each of the following, find the payment size and the total paid over the life of the loan, including points. Option 1, 7.5% compounded monthly with no points. Option 2, 7.25% compounded monthly with 2 points. Option 3, 7.125% compounded monthly with 4 points. Part B. Which loan in Part A has the lowest total cost over the life of the loan? So the solution. First, we analyze the data. P is equal to 100,000. N is equal to 25 years. Multiply by 12 because it is compounded monthly, we have 300. In option 1, we have a 7.5% compounded monthly, so we divide it by 12, we obtain 0.00625. In option 2, we have 7.25% compounded monthly, so we divide it also by 12, and we obtain 0.006041667. In option 3, we have 7.125% compounded monthly, so we divide it by 12, and we obtain 0.0059375. With points is 1% charge on the amount borrowed. So 100,000 multiplied by 0.01, it is equal to 1,000. 2 points, it is equal to 1,000 multiplied by 2, it is equal to 2,000. 4 points, it is equal to 1,000 multiplied by 4, it is equal to 4,000. Now for the cases 2 and 3, we need to add the value of the points. Option 2, P is equal to 100,000. We added 2,000 and it is equal to 102,000. Option 3, P is equal to 100,000. We added 4,000 and it is equal to 104,000. We need to find the payment size for each interest rate, so we have to find R. If we are using Excel, we can find R by selecting the formula Pago. Then it shows us a chart like this. Tasa is equal to I, N per is equal to N, BA is equal to P. Tipo, if it is an ordinary annuity, we have to put 0, but if it is an annuity due, we have to put 1. So we enter the data and then we get the result. So the image is the example for the option 1 and the result is 738.99. As the result of applying the formula on the different cases by ordinary annuity, we get the next values. Option 1, 738.99. Option 2, 737.26. Option 3, 743.36. These one are the payment size for each interest rate including points. To know the total amount paid over the life of the loan, we only need to multiply R for the 300 months equivalent to the 25 years. So option 3 is 738.99 multiplied by 300, it is equal to 221,697.35. Option 2, 737.26 multiplied by 300, it is equal to 221,178.90. Option 3, 743.36 multiplied by 300, it is equal to 223,009.25. Total paid. In option 1 we have 738.96 234.40 multiplied by 300, it is equal to 220,320.35. Option 2, 732.84 multiplied by 300, it is equal to 219,850.74. That is the lowest total cost. In option 3, we have 738.98 multiplied by 300, it is equal to 221,692.95. So we get the present value of these amounts, and we notice that are not the initial 100,000. So option 1 is equal to 99,378.88. Option 2 is 101,387.45, and option 3 is 103,386.14. So we subtract the 100,000 to the present values, and we've got the next values. Option 1 is 621.12. Option 2 is 612.85. Option 3 is equal to 613.86. This is the amount that misses to reach the 100,000. So we calculate the nominal amount by applying the same method we used when we found the total paid over the life, just like this. 621.12, it is equal to a rent of 4.59 multiplied by 300, it is equal to 1,377. In option 2, we have 612.55 with a rent of 4.43 multiplied by 300, it is equal to 1,328.26. In option 3, we have 613.86 with a rent of 4.39 multiplied by 300, it is equal to 1,316.30. So we only need to add this amount to the one we have obtained before. In the video it is explained, and we obtain the next values. Option 1, it is 2,697.35. Option 2, 2021 178.90, and option 3 is 223 9.25.